To us, so we're going to tell you again. Some of you listen, and I like those people. Alright, we need a web admin. If you kind of want to help out with just like general web stuff, we could really use your skills. Keyboard's pretty busy. We're trying to do like as much as possible with the website, but like flipping through our fingers and kind of like forgetting about the stuff. Having a web admin would really help. If you have the keyboard, if you want to apply, just like send me a message or email or something, but really use the web admin. Next top, you want to come up and give a talk on that?
Hello everyone, I'm back. Alright, so, like I mentioned earlier, for those of you that weren't here, next top, competition this semester, anyway, learn with a trial by fire. So this year, it's going to be March 30th and 31st. Gonna get to that part. So it's going to be March 30th and 31st this year. Like I mentioned, 2-day competition. So for teams, we compete with teams of 5, spots for 10 teams. So we are really excited. We now have team setups.
So if you want to practice your red teaming, you can kind of do that. We have like pen testing, CTF going on. There's a whole lot going on that weekend. It's a lot of fun. And if you're like, I've never done it before, it doesn't matter. You'll learn. I promise you don't need to know this before you do it. We have spots for 1, and then conditional. There might be spots for 2 RIT teams. So teams consists of 5 people, and it's $100 per team. You can pick your t-shirt or prizes. At least 1 team, and then like if you do the second team, you might get in if you're the second team. That's a sponsor meeting. How many sponsors? Okay, yeah. 1 or 2 more, yeah. So there's already 2 signed up. So I So there could be up to 5 RT teams, but there's going to be a team. So keep the 5. How did we do that? Did we enter our link or did it talk to you? Yeah, so if you just search ISPS normally, you're about to find something. If you don't want a blue team, you're like, I don't want to pay $100 to be hacked. Be really good at stopping them, or come help us white team. So it's a big competition. There's a lot going on. White team, blue team, but yeah, we have at least like one spot guaranteed. You're really good. All right, we have a decentralized interest group run by Hector. Hector, do you want to stand up and do a plug about this? All right, thank you very much. There we go. All right, thank you, Hector. All right, tonight in the labs, official start time is?
I got this one.
You got this one?
Say too.
That's the next slide.
Oh,
Oh, wild.
yeah, so Halo Night tonight, 8 o'clock in Sec Lab. Come on through. We'll be poning some noobs. Russ is flexing. He thinks he's going to win. So come take him out.
What time is it?
8 o'clock, Sec Lab. Oh, yeah. And then our first ever hackathon next Friday. I think there's like 5 tickets left, so if you still want to do it, sign up now. The sign-in link is in Workplace, and it is a 24-hour write malware, write blue team tools, build something security-y malware, and just hang out. We'll be providing food, I think like 4 or 5 meals or something, and yeah, I don't know. I can't say anything else about it.
Yeah, is it? Do we choose the winner of the best project too? Is that a
That's
thing?
to be determined.
To be determined.
We might have a few guest judges.
Oh wow, it'll be fun. Like, so if you just like have like maybe a lab for CDT where you have to write a red team tool, maybe come by and we can all write red team tools together. Yeah, so it's just going to be like an excuse to hang out. It's not going to be like a formal hackathon. Just us having a good time with a bunch of food at early in the morning.
If you make something cool, you can also put it on your resume as a cool side project too.
That's true. And if you don't know what to do, then it's a great place to find people who are doing cool stuff and maybe jump in on their projects as well. So it's going to be fun. We're basically just going to be like after club till like noon the next day or something. So it's going to be a good time, and we're all not going to sleep or sleep in the labs, which is also always fun. All right, here's our sponsors. They're kind of always changing due to HR departments, but they come in and out. So yeah. We really like our sponsors. They help us out. They allow us to do all this stuff, buying pizza every week, doing cool competitions for you guys. So just if you ever see someone from one of these companies, just be like, thank you. It means a lot to us. And we want you guys to be really good security people who go out in the industry and then represent our IT well. So we appreciate our sponsors. But yeah, just keep that up to date. It's good to know. All right, news. Where's the escape on a Mac? Is it just this little X? Oh, there we go. Oh, look at that. I did not use Macs. Zero experience. All right, so we're going to do the news. There's actually some pretty interesting stuff this week. This one's pretty cool. So Microsoft Exchange. All right, who here knows mail servers? There's one thing I love to hate on. It's mail servers. So basically in the industry, people use like one mail server, unless you're Google and you write your own. Everyone else uses Microsoft Exchange. Really, really, really common in the industry, and this has a 0 day, and it's really cool. It takes you from being just any user, so like if you just fished some random person, to domain admin, just all through Exchange. So it's really interesting. It's actually like a chain of a couple different things going on here. So you can see here like step one, they have the Exchange web services where it's like all the management for it, but you can trick that into going to a custom website to sign in. So Exchange, the service, will be like, hey, I'm just going to go sign in to this random website that the user has tricked me into going to. And along with it, the NTLM hashes will go. And so then that website can be set up to kind of like capture the NTLM hashes. So after that, it doesn't like do any signing or sealing. You can see like it's a series of misconfigurations in Exchange that are all by default misconfigured. So once they have the NTLM, they can then go and they can sign into something else and then modify the domain. And because this says it here, so I'm just going to trust it, but they say most Exchange servers are set up to have permissions to like do a lot of really powerful things on the domain, and then they can just abuse those permissions. So they haven't actually released a patch for it yet, but there's mitigations just by like disabling some of these features or like making sure that your Microsoft Exchange server can't screw with your domain or like set passwords or whatever they're going to be doing to get the exploit. But there's a whole Python tool if you want to read about it. It kind of just automates this whole process. So I thought that was pretty interesting. Next up, we have the FaceTime bug. I'm sure a lot of you guys have heard about this. It's really actually kind of scary, sort of. But what it was is FaceTime would allow you to call someone, and then it would be ringing on their phone. So like, if they're calling and they're not picking up, but it's still just ringing on their phone. What the person who's doing the calling can do is they can go in and they can add a phone number to the call. So like they could just type in their own phone number and add it to the FaceTime call. And then from that phone, you could hear the audio from the other person who was receiving the call's device, even if they have not accepted the FaceTime. So if you just kind of like left your phone at your desk and you weren't like, and you didn't hang up when it was like calling on FaceTime, they could just be listening to you or something like that. So it's like kind of interesting. It's actually, I don't know, has Apple patched it? Does anyone know? This article doesn't mention if Apple's fixed it or not.
4 hours.
Did they? Okay.
That's not a patch.
I thought they just said you just, I thought the mitigation was just don't turn on FaceTime.
They said they were pushing an update later this week.
Okay, yeah, because
they have 72 hours due to GDPR to do something. So.
Okay. Did they get a fine for it?
That's up to someone who decides to say.
That takes forever? Okay. Yeah. So it'll kind of be interesting to see how this plays out, though. What?
Top line says they took it offline.
Yeah. I was going to say, they did something drastic.
Okay.
So there's just no
They just took, okay, they just, yeah. So they didn't actually fix it. They just took all group FaceTime offline. But and Professor Olson, if any of you know him, he was talking about, too, like, it's at a time after, I think it was the GCHQ he mentioned, where it's just like, hey, we want to be able to, like, listen in on people's things by, like, adding phone calls to, like, other phone call, or adding phone numbers to phone calls so we can just listen. So he's like, it's a little suspicious there, but it's probably not attack. It's more likely just a bug. So I just thought that was kind of cool, and Nick did as well, because he added it to the news. So, all All right, the last one, hackers abusing Google App Engine to spread PDF. This one is actually like, it sounds like they're like abusing something of Google. It's not that bad. It's basically just a Microsoft Office macro, and you have to go in and they would just send a message to the user that would be like, please say enable all content and trust this file. And then the user would trust the file and then run the macros. So it wasn't like an exploit or anything. It was just relying on users to just read or click on whatever the thing tells them to click on. But the part where Google App Engine comes in is they were able, I don't know if you can see this, it's kind of small. They were able to basically make it come from appengine.google.com as the URL. So then it was like a trusted link when it was coming through spam detectors and stuff. So like they would be like, oh yeah, I guess it looks legit. It's coming from google.com. So that's kind of where that comes in. Not so much a vulnerability, just you're able to send a redirect through Google. So that's kind of where all that's from. So there's 3 articles for the week. It's always good when there's no data breaches, but there might be data breaches that we just don't know about. So that's not good. But I like not hearing that like 1/3 of America's Social Security numbers are compromised. That always is reassuring. All right, that's all we have for the news today. I think we're going to get started on actual research now.
That's cool. I'm here. All right, cool. Hello. So, we're going to have a short day today. If you've noticed, we only have 3 presentations, not our usual 4. Just giving you a fair warning ahead of time. But nonetheless, the quality will still be there. So first up, we have Scott Brink, who is going to be presenting on a topic that on No 4.0, no problem.
Do you have HDMI and a dongle here? Oh, look at that.
Literally just plug and play.
I'm happy we have Macs so we can spend more money on adapters to make things work.
Hell yeah, let's go.
Oh, also I'll need to high-five you in a little bit.
Oh, because we have no classes?
Yeah.
Okay.
It's actually in my speaker notes too. Oh, wait, hold on.
Are hackers bad?
Why do you think it's crossed out? Yeah. Hey guys, my name's Scott. I'm going to be presenting on No 4.0, no problem. Already a question.
Who's that dog?
Who's that dog? It's a white Pomeranian. You'll see him throughout every single slide on the presentation.
Is it the same dog?
No, never. Anyways, and also if someone asked if it's my dog, it is not. Anyways, like I said, my name's Scott. I'm a 4th year CSEC. I'm the tech lead. I do not have anywhere close to a 4.0 GPA, and I have no class ever. Like seriously, no class ever. It's great. This is my schedule. And Nick doesn't have classes.
Say your GPA on the stream right now.
I have 9 credits and 2 online classes, and Capstone only has a meeting. It's really nice. Yeah, it's really good. So what we're going to talk about first, this is talked about earlier in RITSEC, I think it was probably week 3 or so. Everyone experiences something called imposter syndrome. And TLDR on that is thinking everyone's better than you. And if you want a more in-depth on what everything is, there's a link there. I'll share the slides after so people can actually click on these links. And if you also realize that dog right there, not a real dog. It's an imposter. So, oh, hold on. So, I've spent all of news putting these memes in these slides, so I hope you appreciate all of the Pomeranians. So, when I was a freshman, I came in here and I knew literally nothing about anything. I had done basic Java programming. By week 2, I had no idea what was going on in CS1 anymore. So right now, most people, and this is going to be mainly focused towards CSEC because I'm a CSEC major, that's what I went through. I took routing and switching, Introduction to Routing and Switching, which is a really good class, a lot of information, but it's a dense class, and if you come in with no networking knowledge, it's a lot harder. So I took the midterm, and it's an online My Courses quiz. There were like 100 questions. I had no idea what was happening. There were a lot of letters everywhere. I got it back, and I got a 28 out of 100. Immediately after that, I left the lab and called my mom and said, yeah, this is too hard. I'm going to switch out of this. I don't like this anymore. And that's the exact date because I looked it up, and that's when I turned in my 28 out of 100 on My Courses. Really, the average for the class, though, was 31. So yeah, it was pretty good. Do you have a question?
Are you willing to say who taught? Actually, that never mind.
No, it was department average.
Okay.
Department average is that low. Yeah. We can talk after if you'd like.
Sounds good.
Take it off the line.
So, college is like way harder than high school. A lot of people come in from high school and think, oh, in high school, I really didn't have to do much. I kind of just cruised through all my classes, didn't study, I got A's and B's. I tried to do that my first semester. It didn't work. My first semester, I probably failed a couple tests. I got a D on my CS1 project. And yeah. So most people come in and you think, oh, all these people, like all these e-board members, these people presenting, everyone must have like a 4.0 and they must be so smart. No, school's hard. So people mess up. People fail classes. I've not failed a class. I've come very close. People withdraw from classes. I've withdrawn from a class. And I know other e-board members, they've failed classes, they've withdrawn from classes, and people retake classes. I've retaken a class. Yes. That is the class I retook. So that was my fault. I didn't turn in labs. Fun fact, you should do that if you want a good grade. So what I was going to say is you're not in it alone. We've all taken these classes. We've all been through, wow, mechanics is really hard. I don't know how all of this is working. Wow, these network services labs take 10 hours each. They're so long. The write-ups are so long. I don't know how to do any of this. Why is my router not working? Oh, I don't know anything about networking, which was my entire routing and switching career. I have a minor in it. So, so you ask anyone around, all upperclassmen, like if you ask me, like if you're having issues on routing and switching lab, you can come talk to me. You can come talk to probably most upperclassmen or anyone who's taking the class, and they would be willing to help. And we can also provide resources to other places that can help you. So here is the non-updated curriculum because I can't find the updated one online, unfortunately. So this is what an old flowchart looks like. Here are all the classes. There are a lot of classes. As a freshman, you've probably taken barely any of these. So you're like, wow, I don't know how I'm going to get through all of those, and I don't know who has taken most of them. You come to a senior like me who has no classes. That's because I've taken all of those. Those three right there are the only classes I have to take left. So if you have any questions on any of the other classes, I'm here, and any 4th and 5th year is in the exact same position as me. So we can help with pretty much any class you've been in.
Scott, do you need help with your free elective?
Do I need help with my free elective? Yeah, I got someone else in the class. It's hard. I have to read.
That is tough.
Reading is really hard.
Why do you take a reading class?
I don't know. There are numbers. What am I reading? Nothing. Resources for improving academics. Specifically, we have CS Tutoring Center. That's on the 3rd floor. I have no idea what the room number is. I didn't go to the CS Tutoring Center for my first year for CS1 because I'm like, oh, I don't need to go to the tutoring center. I did very poorly in CS1. Then I went to the tutoring center for CS2, and it helped me out a lot. I was able to understand everything better because their entire job there is they have TAs that are there to answer your questions and help you learn. It's a really great place to go to. SecLab has some TAs. There are schedules for that online. Same with the IST labs and networking and systems administration lab. They always have TAs there. The Society of Software Engineers, if specifically CSEC, you might be thinking, oh, we're not in SE classes, we don't need to go there. They're good for helping with CS, and they have test banks. And test banks are good because you can see old tests, and sometimes they don't get changed that much. And something I found while I was looking this up, we have the Academic Support Center, Tutoring Center here on campus. Their website, which is found there at that link, has links to every major and then subsections of the exact room numbers and the times and schedules that you can go to each of these places. Question from Mike in the back.
I did that with math, lifesaver. You're bad at math, the ASC will literally just like help you through it. I would not be graduating if it wasn't for the ASC.
Yeah, especially for math, because math is really hard. E-board members, all e-board members are willing to help out. And I would assume pretty much every RITSEC member would be willing to help out any of the underclassmen if they're having issues in any of their classes.
Or upper.
Or upper?
Help each other, not just.
Or yeah, or help other people who've taken the classes before. Underclassmen can also help upperclassmen.
I haven't taken sysadmin 1 yet.
You haven't taken sysadmin 1? Aren't you a second semester, third year?
Yeah.
Cool.
Okay.
So let's say your GPA, yeah. So everything I just talked about was for making sure you can up your GPA. And GPA is definitely an important thing. The higher your GPA is, the easier it will be to an extent to get a job. But let's say right now, oh, my GPA is at this value. But career fair is coming up. I can't change my GPA. What do I do? So there are a couple things right here. We have projects. So actually, that link right there, we have a link to Micah's talk last semester on where to start on projects. Because if I just say, hey, just do a project, a lot of you would be like, I don't know what kind of project I could do. That will help you. It'll give a bunch of ideas on how to actually start doing projects. Or you go to things like the RITSEC Hackathon, and we'll be able to help you out with stuff there. And another thing, which is the most, in my opinion, for my resume, I don't have as many personal projects, but I have tons of competitions there. Every interview I've done, we go over a couple school things, and then we talk about competitions for a majority of it. Ben?
My GPA was below 3 for almost my entire career. I still got
Yeah, mine.
no paying companies.
Yeah, mine barely got over 3 like 2 semesters ago.
2.9 region.
Yeah, that's about right. So even if you're not over 3.0, believe it or not, you can still get a job at really good places too. So, do you have enough? I was just going to go on to competitions. So.
Kind of pulls in what Russ was saying last week about selling yourself. You can't sell your GPA, you can sell these things on the slide.
Yeah.
If you're self-reply, your GPA doesn't matter, because my GPA doesn't reflect how good I am at CSEC.
Yeah. Because, yeah, when I got my first co-op, my GPA was like 2.7, 2.8, somewhere around there. But I had ISTS, IRSEC, Lockdown, and a couple CTFs that I had participated in. And I put all of those on my resume, and that was a majority of what we talked about. So all of these competitions, we have ISTS, IRSEC, CCDC, Lockdown. Those are all the red team, blue team competitions. We're going to get there, Joe, don't worry. I saw you looking at NSIC. We have the red team, blue team competitions. Lockdown and IRSEC specifically are really good for beginners. And even ISTS is very good for beginners, and people can still sign up for that. We have, what, was it 2 teams?
1 to 2 left.
1 to 2 more teams can sign up for ISTS. That was the first competition I did, and I had no idea what was going on. When I went into that competition, I didn't know that you could have a Linux VM without a GUI. And yeah, right? But going into those competitions, even if you have no idea what you're doing, I think it was the best choice I made in CSEC, and it's what really drove my passion in CSEC, was doing all of those competitions. And the last one is just be involved. Like, coming to these meetings, that shows you're involved. Doing the competitions, doing projects, just everything in general, just try to stay as involved as possible. Asking questions is another huge thing. If you don't know, let's say the demos, for example, I'm going to go tech lead. if you have no idea, let's say you did the web challenges, you got maybe one of them, or you struggled to even get one. I put the write-ups out, and like I said, I have no class. Message me, and I will even come sit down with you and walk you through, and you can ask questions all the way through all 5 of the challenges. I have that kind of time because I don't have class. I do not have class. Just make sure everyone knows that. No class. All right.
What time do you have class?
What time? Never. Anyways, any questions? Questions, comments?
Can you do my homework since we have so much time?
No, I can't even do my own. Yeah, you can raise your hand.
God damn it, I raised my hand. Are you Class E if you don't have class?
Ooh.
Fuck, no one laughed.
Oh. I like the effort, Joe.
Does that dog have class?
When I graduate, will I get this kind of dog? Maybe. We'll see.
Does the dog have class?
Any more questions that do not relate to dog or the fact that I don't have class?
Shameless plug. If you don't know where to start on a project, join a mentorship group. That's what they're there for.
+1.
Where have you worked, Scott, with your less than stellar GPA?
I have a full-time offer at IBM right now that I've accepted.
Ooh, get it.
This may sound like a joke, but I promise it's not.
Okay.
If having a really high GPA doesn't matter that much, does it mean I'm cool if I stay up really, really late and never ever go to class?
So, no. I said that the GPA, it doesn't matter to not have a 4.0, but trust me, having the 4.0 helps out a lot. So if you can keep your GPA high, try to do that. You shouldn't be skipping all of your classes and just focusing on, oh, look at all these cool projects I do. Look at all the competitions I do. And then you have like a 1-2. You should try to first maintain your academics and then do your cool security stuff. All the way in the back.
It's like GPA isn't the only thing, but it is a thing.
Yeah, it's one of the things that helps out. It is not the defining factor. Like if you don't have a perfect GPA, it's not going to kill you. Ben?
From a recruiter's perspective, if you have 2 resumes in front of you, someone CSEC who goes to the clubs, then does some projects, what's the differentiator? GPA at that point, right? If it's only a bullet point about your project, I know there's nothing else in the title, and mine are all NSA name generators from my project, so it's not descriptive at all. So like it's a bullet point, right? So GPA can be a factor, but you have to think about it. If you're looking at a resume, that's what it comes down to.
Yep.
And I will say anecdotally from my experience with people I've looked at, I've definitely noticed that the people I know who have maybe not as great a GPA but a lot of really good projects and clubs, that does seem to help out in the inverse of having a really good GPA but no niche and no like what are you doing?
Yeah. Definitely agree with that.
And just an addendum, there are certain teams, like the Collegiate Cyber Defense Conference team, that has a GPA requirement. So if you're below that, you may not be able to do some of the things that you want to do. So that's another door that gets shut.
What is that?
You were about to ask the question, I was about to answer.
3.25?
That's correct.
Look at that.
So if you're above that, you're fine. But yeah, that.
Any more questions? Questions, comments, anything? No? Cool. All right, thanks, guys. Oh, also, here's my contact info. If you want to give me some money for more monsters, I'm addicted. And yeah, there's a credit for the theme.
Go back. You want to take a picture of it?
Do you want to take a picture?
What do I get if I donate?
What happened to all those monster cans?
Oh, we still have them. Something's happening.
All right, thank you, Scott. Thank you, Scott. We still have 2 presentations left. 2 presentations left. The next presentation on the block. If we calm down a little bit. Just bring it down a little bit. Got to do some presentations here. All right. So the next presentation on the block is going to be by Mr. Owen, and it will be on Windows and Wi-Fi passwords. So if we all just give a little hand for Mr. Owen. He will walk down here. He will be presenting on a Microsoft Surface. It does, in fact, have a dongle. He is now approaching the stage and will now inject himself into the cyber.
I thought you injected the cyber.
Nope.
Maybe. Please no.
Which isn't that hard to do on Windows. Why is your taskbar at the top?
Because it's superior.
Okay.
Mic check. We good? Excuse me, streamer. Mic check.
All good.
Perfect. Ooh, hello. All right. So today I'll be presenting on Wi-Fi passwords in Windows, a story of how a Reddit post became this presentation. So imagine about a week ago in air gap, Nicholas O'Brien comes up to you and says, "Would you like to present this week?" I said nonchalantly, "No, but maybe next week." Then a few days ago, I received a message. "So what are you presenting on this week?" Yeah. So, all right, I am Owen. You can find me in all these places. And I thought maybe I'd put my Reddit up because I kind of got this presentation off Reddit, and I realized that's a terrible idea. We're not going to give you my Reddit. You don't need to see that. All right, so let's get down and dirty. So I was scrolling through Reddit, and I see this post on r/command line. It said you can post this, paste this in CMD and get all of the Wi-Fi passwords. It is described as a masterpiece by the original poster. So being the casual CSEC kid I am, I posted that bad boy right in there and had no thought of repercussions. So kind of breaking this down, I was like, all right, NetSH, I know that does some things. I've used that before. We got some fine strings. So I was like, can't be that bad, right? So I do it, and I get a bunch of things, and a bunch of plain text Wi-Fi passwords. So I was like, interesting. So I kind of just started diving deep into what it did. There was also a PowerShell script, which was much better written. And I got even more. So this is all of the Wi-Fi SSIDs that I have saved on my laptop. And all of the passwords were there in plain text. Don't worry about it. So I started looking and doing some research on where Windows keeps these passwords. So Windows 7 and older kind of kept them in the registry. And then from then on, it creates XML files in this program data path here. So if you look in the registry, in that path, there's an interface section for each interface that you have, and then profiles for each connection. And in each profile, you get all of this stuff. I don't really understand the registry, and I didn't really know what to do with this, but here it is. So I okay, connection type, probably something to do with wireless or whatever that number means. But that was scary, so we left and went to the XML files. And here is a full breakdown of the connection to my apartment Wi-Fi. If you want the password, just ask. So I was looking at it, I was like, okay, so let's start breaking this down. What do we have here? We have the SSID, all right. We have the encryption types. And this was a passphrase, but it was encrypted. So I kind of was curious, how do we get from this encrypted state to the plain text thing that just kind of popped up in PowerShell? Well, I will tell you. That crypto part. So at the beginning of each key for each encrypted password had this signature. And apparently that is a built-in C++ library that Windows uses called crypt protect data. And apparently that's very simple to reverse if you just pass that into crypt unprotect data or running at system level. So yeah. That's about it. It was a short and fast one, short and sweet. Just how I like it. Any questions?
Is it over?
Any questions? What's up, Sam?
So,
Please, no hard ones.
The data, is there, where is do we know where the key stored for that?
Yeah, in that XML file.
Oh, okay.
And it just.
So it's directly stored in the XML file
Yep.
that everything else is being stored in?
So there's each connection has their own XML file. So this is just the one that I used for our apartment Wi-Fi.
Wait, so it has the password right next, and then also in an XML file is the encryption key for that password?
The password is not in here. This is just the encryption key, and it's actually a lot long. It was a very long string, but the key material is how it's described as. And then that is generated by passing an unsalted password into crypt protect data. Yeah, so I was like, oh, that's kind of cool. And again, it's pretty easy to decrypt with the crypt unprotect data. And I left a bullet point. Shit. Anything else? Cool.
Thank you very much.
Short and sweet.
Yeah, don't forget that. Leave that. Ooh, a Lyft notification.
Ooh, you got a ride coming?
Unlimited rides for now. So, our last presentation for the day is going to be by Senor Brandon Adler. You might know him by Scuzzy. He is going to be...
I should have added that.
Yeah, Scuzz 3Y. He's going to be presenting on ARM trust zones. ARM is in the ISA, well, you know, the instruction thingy.
Yes, that one.
Is it an ISA?
Kill him. No.
Okay, that's why I stopped myself. That would be the instruction set architecture, sir.
No, that are the instructions that get executed on the hardware. Thank you.
Okay, so
Got him.
this is why he's doing the presentation, not me.
Got him.
All right, let's get this.
Yeah, go
This
Brandon.
dude's set up.
Back to presenting.
All right. Where's this HDMI? Here it is.
Dude, you're looking like a military man right now with that walkie-talkie on the pocket. All you need is the phone in the holster on the left, too.
Exactly. Oh, it's extended. That's no fun.
Yeah.
Please hold.
Yes, this guy doesn't have speaker.
Hopefully I just didn't release. Nope, I do not do speaker notes. So I have tested the presentation though, just for the record.
It's a cool browser.
Yeah, Vivaldi. Everybody should try out Vivaldi. Highly recommend it. It is built on Chromium, but it is not Chrome. Okay. So I will be presenting on basically what is the ARM trust zone. But first of all, who am I? What do I do? So I dual boot Windows and Arch. Let's go. Any Arch users? Arch users? Arch users?
I have a VM.
Come on. All right, I'll take that. I'll take that. So highly recommend if you want to learn a little more about Linux, install Arch. If you have supported hardware, it's going to be a lot easier. Any ThinkPad is really supported hardware, just for the record. I will not help anyone without supported hardware because that's out of my scope. I don't know how to work it without supported hardware. This year, I'm the CCDC team captain and 4th year on the team. I've been doing Windows Red Team for the past couple years, mostly on persistence, how to persist on the box. And I'm currently working on 2 ARM-based projects, one as an independent study, and the other for MITRE's eCTF competition this semester. I think it's the 3rd annual, which they've both been pretty interesting. So just a quick overview of my independent study, because that's kind of where the research for this presentation has been kind of pulled from while doing research for my independent study. So just a quick one-liner on what my independent study is. My job is to implement in the open source TPM released by IBM. It's basically a C project, and implement it in the secure world of the ARM trust zone on a Cortex-M processor. So, wow, that's a lot of things. What are these things? We will get into most of them, such as mostly the trust zone and ARM Cortex-M through this presentation. I won't be covering the TPM portion since I haven't actually got there in my research yet for my independent study. And we're going to be going over why trust zones are important for security nowadays and what is it in an overarching manner. So first of all, I'm going to do a little diff on the difference between a Cortex-M and Cortex-A. So just for reference, the Cortex-A is what most people have as the processor in their phone. So it's a pretty high performance processor. It can have up to like 4 cores, generally 4 to 8 cores, depending how powerful the chip is itself. And it has very high power consumption, large instruction set, and you can actually run an OS on top of it, right? Most people's Android phones, they run a Linux kernel under the hood, might be slightly modified, but still an OS nonetheless. So the Cortex-M, though, is very simple compared to the Cortex-A, even though both of them implement the trust zone feature implemented by ARM. And it's really just for embedded devices or applications. It runs basically just a firmware. There's no operating system that runs on top of the Cortex-M. It's made for low power consumption, and it's honestly just meant to be very simple to use in like SCADA networks or IoT devices. So I'll just go over this quickly because some of this is slightly important from the trust zone perspective. So a couple of the physical differences of the actual components that you would see on the chip itself are more CPU cores, obviously. There's going to be more cache for the Cortex-A CPUs just because of the instruction set and to cache as much as they can so they can obviously process data faster. And one of the most important things that you can see on the Cortex-M23 over here that has to do with trust zones is the memory protection unit. I'm going to go into this on the next slide, I believe, so I'm going to go there. So this is just basically a feature diff on the different features between the two. So the Cortex-A has a couple different contexts that the processor can be in, whereas for the Cortex-M, it's really just 2 contexts. There's a secure thread for the secure world and a non-secure thread for the non-secure world with handlers for exceptions. So the main thing we're going to get into through this presentation is the state transitions and the memory management. So for the Cortex-A, you can pretty much think of this as a regular x86 CPU for if you know how that works. So right, processes are isolated with virtual memory that's given, and the user land on any modern operating system that you use nowadays is isolated from the kernel land memory. So that's pretty important in the isolation of keeping things secure, right? And the Cortex-M doesn't really have that, though. It really just has a piece of hardware that gets configured at boot time that says, so if the unsecure land, it tries to access memory from the secure world, then we throw an exception because that shouldn't happen. Untrusted code should never be run, should never be able to access the trusted memory of, let's say, the kernel, right, for comparison. So just covered a couple of this, but just important takeaways. So MPU, memory management unit versus MPU, memory protection unit. MPU is very simple compared to the MMU that's implemented on the Cortex-A. State transition differences. Cortex-A is a software state transition. So the stack is actually, the stack transitions, right, between the worlds is done in software. So it's done basically at compile time. But it's for the Cortex-M, it's actually done by the hardware itself. So nowhere in the code you're going to see like registers getting pushed to the stack, right, and cleared, because that's all done in the hardware itself. So finally, we reached a diagram here. Hardware-based software isolation. So this is one of the most interesting things probably that I learned while researching the trust zone, because most of the things that you think happen in hardware on an x86 CPU are really just happening in software. So it's pretty interesting to think about the hardware actually doing some real work and making very fast state transitions between the non-secure and secure world. And so this actually allows a secure application to control the non-secure application's access to the system itself. So I'll have a better diagram for what that actually means in the next slide, I believe. But you can just think of the secure world being used kind of like a library for the non-secure world, which kind of keeps it isolated from all the hardware, all the system resources, right, that you might deem not necessary for the non-secure world to access, like encryption keys, for example. So this is kind of more a definitive picture or diagram for how the accesses actually occur. So the non-secure callable memory is really just a portion of the flash that gets set basically at boot time in NVRAM, or in NVRAM that gets set to the processor, right, at boot time. And the secure gateway instruction is actually the instruction used by that intermediate library to transition, tell the processor to push everything to the stack, zero out the registers, and now we're going to run code in the secure world. So that right there is very interesting because x86 has nothing even like close to this for the sense of security and process isolation, because it just wouldn't be as fast, I guess. Well, you can't run an OS, right, that does this. This is just firmware. So this is specifically the Cortex-M implementation, I should have noted. And with the secure world can actually call code or functions in the non-secure world if it implements something that, let's say, the secure world should access. This can be like a user library function that the secure world needs to know where its data is, right? And there's a little less of a state transition there because it's assumed that the secure library is written securely. And that's generally a large assumption, but usually one that's made, you know, throughout every computing device you use. Something's always has to be known or assumed is secure or trusted. So this is actually how direct memory or access is prevented. So when the non-secure code tries to call a function that the secure world provides, it has to go through this non-secure callable code, or we can just say the non-secure gateway, right? So the only thing this non-secure gateway does is the state transition. It doesn't have any functional code inside of it. It really just makes a hop from the non-secure code to the secure code. So that's super important because then the non-secure code can't make a direct pointer to the memory that a function lives in the secure world. So that itself is just entirely isolating that memory space. And even if the non-secure world gets a direct pointer to a function in the secure world, it could be any function, any memory, right? Because if you try to read memory, it could be an encryption key, it could be sensitive information. That'll actually trigger a secure fault exception, which is what happens when we saw the handler beforehand. So there's a thread and a handler. And exception handlers would be running if this secure fault exception occurs to try and see what happened and diagnose if we have to reboot the system, can we just restart the client application, or anything like that, any type of remediation that would occur from this exception. And there's a couple different things, but as you can see, for the non-secure code to even access the secure code, it has to go through this library, use the SG instruction, and then that library itself, which when you're actually writing the code for this, that literally gets compiled to a library that only has the function definitions for what the non-secure code is able to call. So let's say we want to turn an LED on a motherboard, right? It's going to call a function defined in this NSC. It's going to go to the secure world, and the secure world actually does the work for that. So just try to think about it that way. So any access to most hardware, that's going to go through the secure code because you don't really want to give hardware access to somebody who could do whatever they want with the hardware. So one of the biggest kind of like interesting things about this project is that we're in like the computing world, we're normally used to, you know, we have code that runs code and our application gets run by an OS. In this project, none of this is a thing. This is literally just sequential operations that might have a state transition in the middle. So on the left-hand side, this is the entire portion of Flash that would be used for your program. So when we think of like how Windows runs, how Linux runs, this is like a drastic difference. Because we don't even need a bootloader, right? If we go on the right, so the most simple way that this works, right, is the hardware starts executing code from memory 0 in the Flash. So it starts reading in data from memory address 0 and starts executing that in a sequential manner. Super simple, and it took way too long for me to see how this actually worked, because there's like tons of documentation at like the hardware level of what is actually going on during the boot process. So it was like pretty interesting to go through the process. But basically, as we can see, this app NSC Flash region right here, this is the only thing that the app NSC non-secure can jump to in order to access functions that are provided by the secure world. So it might have access to this memory region itself, but in no way can it directly read arbitrary memory from the non-secure area region, or definitely can't read memory from the secure region, which is the only way it's defined to work, which is it's pretty interesting. So few settings. These are basically the settings that define what these memory offsets are in the Flash. So when you link your program together, you have to define a file that says, OK, I want to put the secure program here, the non-secure callable program here, and the non-secure program here. And this might look kind of cryptic here, but you can basically just place like arbitrary memory values in the place of this equation. And so that's what all this defines. So this boot prot right here, that defines this boot prot variable. And this is done in non-volatile memory, so it knows when the hardware starts that we're going to execute these instructions first, and then eventually this memory region is going to jump to the next one. And that it needs to know that in order to start executing whatever program we wrote. So I won't go over this too much in depth, but this is basically just the same as this, except they have this in the documentation. And so I actually did this presentation for my independent study group a couple days ago, and they were pretty interested in this information, as long as my sponsoring professor. So I kind of like just provided this information for them and showed like how we could set the values in this fuse. So this is actually in the debugger that we can connect the board to our laptop in order to debug the board while our code is running to see the registers, memory addresses, and we can even do a dump of the entire Flash if we need to see other issues that are occurring. So the next steps for my independent study are to take a more in-depth look at the TPM implementation, decide how to port it to ARM, because originally it was written for Linux, which even that is going to be interesting. I'm kind of expecting to continue this as my MS capstone project as well, so we'll see how that goes. We'll see how far we get on this at the end of this semester. Design the model around being the secure application in the architecture. And we don't need a bootloader at this point in time because we can just slap that on later. Bootloaders in this context for embedded devices are mostly just meant for updating the applications themselves. So updating the secure application or the non-secure application to, let's say, version 2. And then begin implementing the actual code. So that's all I got. Any questions? Yep.
You know why they called them fuses? At first I thought you were talking about like the file system thing, and then it clicked like, oh, like sounds like a physical fuse that would break.
So I honestly don't know why. Okay, I'm sorry. So Joe asked why they call them fuse settings. It sounds like it's a physical thing on the board. So in this case, it's not. I feel like you're right. They might have been at some point. But if any of you know what a hardware register is, it's really just a place in memory that a value is set that hardware is set to check. So it might be memory mapped to a different region of flash, not in the main block. But they're literally, it's just another area of flash that these settings are set in, basically. Yeah. Awesome.
Thank you. All right. I mentioned that today would end a little. What's going on, bud?
I didn't realize it was quarantine.
Yeah.
That's what we shut down the government for. It's like 15 people here.
And online. So, yeah, so just another reminder to make sure to come to the Halo Night if you wish to participate in the Halo Night. A disclaimer for all those CCDC people, you had practice tonight, so remember that. Yeah, I hope everyone has a fantastic and fun-filled weekend. This concludes the research portion of RITSEC. Good afternoon, good evening, and good night.